Hello, hello. Hello, Tbilisi. Hello, Georgia. I must confess, this is my first time in Georgia as well, as my colleague. But continuing the theme of culinary preferences, my favorite set for lunch is harcho, 3 khinkali, and khachapuri. I think it's enough for one person. That's honestly, it's my best choice. When I have this opportunity, I do it every time. So, welcome to DevSecOps Inspire. Today, I will focus on building trust in your software supply chain. Very important topic nowadays. It continues making on news, on governments, whatever you can see. I forgot to take a clicker. So my name is Yury Konov. I'm customer engineer in Google Cloud, and my job is basically to serve as an interface between our customers and our services. Typically, I use with larger companies, like we call it medium and large business. I work with CEOs, CIOs, development teams, DevOps teams, security teams, and I help to understand their needs and map it to our capabilities. That's my job, basically. And I think it's one of the funniest jobs in Google Cloud, to be honest. Our agenda for today looks something like this. First, I'll talk about what is secure software supply chain, why you should care about it, what makes this problem kind of difficult, and how Google can help. And after that, I will show you a demo. That's my point. Okay, so what exactly is secure software supply chain? Simply put, it's the journey of the code from the source to development to production. Securing software supply chain requires securing the code itself, but also it requires you to secure all the steps, all the components of this chain. And this includes third-party dependencies, by the way, binaries and other stuff which you put into your software. And also, as the code goes from development to production, each link in this process also must be secured because it represents the attack vectors into your supply chain. And you can see these attack vectors like red arrows here. As an example, you might remember recent quite sounding issue with Log4j library. That's the classical example of compromised dependency injection. That's it. You can think of this journey analogous to any manufacturing supply chain. For example, car manufacturing. Car consists of multiple components. Each component typically is sourced from different vendor, and all those subcomponents, they also have their own manufacturing chains. And if one of these subcomponents has a vulnerability in it, very high chances that this vulnerability will be in your final product, in your car, for example. And it's not surprising that high-profile attacks, recent attacks like SolarWinds, Mimecast, and CodeCov, have preyed on this complexity. In case of SolarWinds, for instance, a third-party dependency was used as a vector to deliver malicious software during the update cycle. So that's the same story again and again. In fact, the threat is so imminent that last year, US President Biden issued an executive order requiring all federal suppliers and government agencies to conform with forthcoming standards and regulations to protect their security, to protect their software supply chains. Also, European Union, specifically Cybersecurity Department, or how they call it, European Union Agency for Cybersecurity, also recognizes it as a problem and orders some instructions regarding this. So far, we discussed what supply chain is and why it's important and why it's top of mind nowadays. And let me next switch to how Google can help in this area. At Google Cloud, we believe two things are foundationally necessary to implement entire secure software supply chain. First, it's industry frameworks and standards. They are critical, especially given the pervasive use of open source software within your code development. Here are some stats. Estimated 84% of commercial code bases nowadays have at least one active vulnerability in it. That says on its own. Having industry-wide standards and frameworks is very important if you utilize open source. But industry standards and frameworks is not enough. There should be something which will implement and which will execute those standards and requirements on practice in your environment. These are typically managed services. These services can in turn allow us to implement these standards and to achieve zero trust software supply chains. Let's look at each of these one by one. So, speaking of industry-wide standards, Google last year introduced what we call SALSA. SALSA is an end-to-end framework for ensuring integrity of artifacts throughout the software supply chain. SALSA represents guidelines established by consensus of multiple players or key players in the industry. SALSA consists of four levels, with each level representing certain level of protection of your supply chain. While level 4 is the ideal end state, but even level 1 is a good starting point, and you can track and measure your progress on this path. In addition to SALSA, Google co-founded OpenSSF, which is a cross-industry collaboration to improve security of open source software. Some other Google projects that you can leverage to deliver open source software securely include Open Source Insights, which is an interactive visualization site where you can explore open source software packages. This is unique in terms of that provides the, how they called it, transitive dependency graph, which is continuously updated with the most recent information about these specific software packages. And it also includes information about vulnerabilities, licenses, and some additional information. And you can browse this graph, and it also includes information about packages from in multiple languages, from multiple repositories. So you can browse this graph to understand which specific potential vulnerabilities there are in the packages which you are using in your software. And last but not least is open source scorecards. It's the website or repository which is constantly being updated by Google and some others, which provide a risk score for open source projects. Now let's look into how managed services from Google Cloud can help you implement zero trust software supply chain based on these industry standards. When it comes to zero trust, establishing, verifying, and maintaining trust via attestations is what makes Google Cloud unique in this area. Essentially, to establish trust, cryptographic signatures are generated as code moves from the source repositories to build process to artifact repositories, that's called general way. And before deployment, these attestations are checked based on policies to make sure that you are about to run, to make sure that what you are about to run in production conforms to the policies which you stand in your organization. In fact, the verification doesn't stop at the deployment moment, and continuing conformance is also very important. This is important because after you deployed something, you might change policies. And at that moment, you would like to understand if this policy change somehow affects your security posture with already deployed software. Now let's look deeper into how attestation specifically can help you establish, verify, and maintain trust. When it comes to establishing trust, attestations are collected in a variety of ways. And by the way, when I say attestation, it's not like general term. It's this specific artifact which is collected based on your software package. So here are just some examples. You can scan your local images for vulnerabilities to generate attestations. Alternatively, you can use Google Cloud to enable automated vulnerability scanning with artifact registry. Likewise, attestations can be generated for manual processes, including QA, code review, among other activities. And finally, with Cloud Build, our service for building, testing, and deploying software to virtual machines, Kubernetes, serverless, and Firebase. With Cloud Build, you get out of the box attestation, which is called Built by Cloud Build. This indicates that build was specifically produced by Cloud Build, and it's scripted, and you can rely on it. If the package has these attestations, you can rely that at least this package came from Cloud Build. Notably, Cloud Build also helps with achieving SALSA level 2. Because SALSA, as we previously discussed, denotes the level of security of your software supply chain. Cloud Build captures the source of the build configuration, not only the source code, but also the source of the build configuration, including the build pipeline and the environment which was utilized to build your package. Cloud Build offers a hosted build service that generates authenticated, what we call provenance. It's the proof of how your package was built, which is one of the key SALSA level 2 requirements. Once the attestations have been captured, the next step is verifying and maintaining trust. Binary authorization can be really useful here. Binary authorization verifies the attestations captured along the supply chain for authenticity, I should say. In enforcement, binary authorization works in two modes. First is enforcement mode, when the image is deployed only when attestations meet your organization's policy. The second mode is audit mode, which allows to deploy anything, but policy violations will be logged and triggers will be alerted, alerts will be triggered, and you can respond to those alerts in required way. But verification doesn't stop at deployment, as I mentioned. Binary authorization also supports what we call continuous validation, which allows for continued conformance of the defined policy even post-deployment. Now, if a running application falls out of conformance with the existing or newly added policy, the alert is again created and logged. In addition to binary authorization, choosing a secure container environment is also very important. At Google Cloud, we can offer you two options. First option is GKE, Google Container Engine, which is, I would say, one of the best in the world, managed Kubernetes services. But specifically for GKE, there is a mode, there is an option when you create a GKE cluster, which is called Autopilot. Autopilot it's not just managed Kubernetes, it's even more. It's more than managing your nodes, scaling, whatever. It also manages security settings, it also manages connections, manages basically everything. You just deploy containers and everything runs in the most secured configuration possible. Another option is Cloud Run. Cloud Run is the serverless service which allows you to deploy and run containers, where again you don't manage infrastructure, and by default the configuration of Cloud Run is very, very secure. Sometimes you even have to uncheck some features to enable some features which you would like to utilize. That was a helicopter view of the current supply chain capabilities of Google Cloud. Now I'd like to show you a demo of how everything we discussed so far comes together. How our tools from source repositories, from cloud build, artifact registry, binary authorization, and the deployment and the running environment. They work together to establish, verify, and maintain trust for secure software supply chain. For demo specifically, I would like to invite my colleague, Victor, remotely. Because, yeah, it happens when we prepare for presentation, for demonstration specifically on stage, in last moments something goes wrong. But we have a backup. We have, how it's called, royal in the garden, right? So, let's start. Oh, it's the conclusion slide. Let's start the presentation, the demonstration.
Hi, everyone.
Let's call Victor.
I'm Victor Salve. I'm an outbound product manager, and I work on securely delivering applications in Google Cloud. Today, I'm going to be walking through an end-to-end development workflow with security capabilities provided by Google Cloud, with the ultimate goal of strengthening your software supply chain security. So let's get started and take a look at the flow. We're going to be going through a relatively typical development workflow, which includes a developer checking in or doing a PR to a Git repository, which will then trigger a CI process. This builds a containerized application, which pushes the image to artifact registry. So artifact registry will actually use container analysis to automatically scan for vulnerabilities in my image. And I've configured my cloud build process with a policy check step. So this is based on open source Critis, and what it will do is ensure that my image meets the requirements that have been set out before advancing to the next step. And if not, my build will fail. Finally, we'll use Cloud Deploy to progress our image into GKE environments in a controlled fashion. You can include things like manual approval steps at key junctures with Cloud Deploy. But I've also enabled binary authorization on this project to ensure that any deployed image to GKE or Cloud Run meets policy requirements. We'll talk about the specific policies I've set out for this project in a moment. So let's talk about the application itself. Now, my application is a simple Python Flask-based application, and I've containerized it with Docker. I mentioned earlier that I'm going to use Cloud Build to actually build and push this application, at which point Artifact Registry will use container analysis to automatically scan my images for vulnerabilities. Now, if those vulnerabilities exceed my policy requirements, my build will fail. So I'm going to be doing that based on a policy that I've set out in this particular file. So in this particular case, anything that exceeds a medium severity, it will basically fail my build. Let's see an example where I build a known vulnerable image before we go and actually look at my application. And let's see how this works in a failure mode. So I've got a build file here that's going to be pulling from my bad Docker file. Okay, and my bad Docker file has an old Debian 9 image which has some vulnerabilities in it. So let's take a look at how that actually works. And I'm going to go ahead and kick off the build. So I can see that I've already got my build started here, and we can actually take a look at the progress as it goes through all of the steps. Okay, so you can see that my build actually failed on this vuln sign step. And this particular step, what it does, as I mentioned earlier, it's a policy check. So it checks to make sure that that policy file that I mentioned earlier, that the thresholds in it have not been exceeded. And in this case, you can see that my medium policy requirement was in place, and we found actually 9 violations within this image, which is why it failed. So let's take a look at this in artifact analysis. You can see that just a minute ago we have an image built with a lot of vulnerabilities, including 12 high vulnerabilities. But I also mentioned another layer of policy enforcement with binary authorization. So in this case, I have a relatively simple policy which I'm going to share. In my binary authorization policy file, I have two requirements that any image must have in order to be deployed to my environments. So the first is that the image must be built by Cloud Build. So it has to be signed by the Cloud Build system to note that we've used Cloud Build to build this particular image. And second, it has to pass my vulnerability policy thresholds, which we just walked through. Now, before we deploy our application, let's again take a look at an example where we try to deploy something that does not conform to policy. So in this case, I'm going to be attempting to deploy a Nginx image, and this particular image has not, of course, gone through the various scrutiny that's required. And we're going to go ahead and try to deploy that and see how that works. All right, so now I can see that I'm waiting for this thing to roll out, but you notice that it has not actually rolled out. And when I go into my workloads view within Kubernetes Engine and I refresh, I see that I actually have here an error message that's letting me know that this particular image was rejected by binary authorization. Now, it also specifies that it had no attestations, which are assurances that this particular image was built by Cloud Build, nor did it go through my vulnerability checks. So in a nutshell, binary authorization provided admission control right before it went into production. But now let's take a look at our application. Let's take a look at the Cloud Build steps that are going to take place here within our CI process, within our build process. We're first going to build the Docker image, or the container image. We're then going to run some API tests. We're then going to go ahead and push to artifact registry. So build, run tests, push, okay? At that point, we're also going to be doing a vulnerability analysis, right? Just like we did in the last example where it failed. And finally, it's going to kick off a deployment if that vulnerability scan passes via Cloud Deploy. And Cloud Deploy is going to progress it into the first test environment. Now, the other thing I want to point out here is that I'm also running this build within what's called a private pool. For added security, we've configured our Cloud Build job to run in a private pool, which provides the ability to peer into private networks. It allows things like eliminating public internet egress if you choose. You can run in a specific region. You can also utilize a variety of machine type configurations. So you can really kind of tailor and customize your build environment. I'm going to be triggering our application via a commit. We'll commit it, and now we'll push. Okay, so the build has finished in just a couple of minutes, and we can see that everything is passed. Now, I'm going to point out that vulnerability scanning requirement, and you can see that in this case, the same policy applied, the medium policy. We can also see that we were able to pass that requirement. So we were able to attain the attestation, which is required in binary authorization. Later, it's also required to pass this particular build step. And see that on the vulnerability side, there's only 3 mediums and 0 highs. So we've actually passed this particular check. Now, the other thing I can do here, and Nikhil talked about SLSA Level 2 compliance, I can inspect the provenance of this particular artifact. So SLSA Level 2 compliance hinges on signed provenance of built artifacts. Cloud Build automatically generates and stores signed provenance for artifacts, which we can inspect at any time. Let's take a look at the artifact provenance for this particular image that was just built. And we can see here that the provenance is stored in an in toto format. We can see the commit that triggered this particular build. We can see a lot of information, including all of the steps that were actually run. And you can see at the end that it also has been signed by Cloud Build. Okay, so we can also now take a look at Cloud Deploy, which likely has started rolling out our application at this point. And in fact, you can see and And if we go back to our workloads screen and refresh it, you'll see that the PopStats workload, the application that we just deployed, was deployed okay, in contrast to the Nginx we tried to deploy earlier. So I hope this demonstration provided a useful view into how Google Cloud's CI/CD, artifact management, and policy enforcement.
Well, that was the demo. I hope it kind of demonstrated the capabilities which I was talking about. If you want to see more, come to our desk. I can show you how this environment looks from inside. Basically, we can try the same stuff, which hopefully will work out of there. So, in conclusion, today we showcased you some ways in which Google Cloud can help you secure the software supply chain. Recent attacks like SolarWinds, Mimecast, CodeCov demonstrate the urgency of the problem. And at Google Cloud, we provide you with industry-wide standards, frameworks to help you secure a software supply chain, Google Cloud managed services, right from source, build, deploy, and run, provide built-in support for many of these industry-wide standards and frameworks. Last notice, don't forget to scan the code, take a quiz, and the quiz contains questions which you now should know answers to. If you forget to do it right now, there is the same code on our desk outside. Okay, thank you all for your time today, and you are all welcomed in Google Cloud. Thank you.
Anyway, what is the biggest threat to supply chain security?
The biggest?
Yes.
I wouldn't say what is the biggest one, because there are multiple threats, starting from people who are not complying with requirements or even hacking you from inside, to the external threats, which can utilize, as I mentioned, dependencies, which is, I would say dependencies is quite important. Tracking dependencies and making sure that everything which you put into your code, which you've taken from outside, is secure, and you must be sure that it is secure. And how you can be sure? Try to conform to follow standards and use the right tools. And by the way, many of the speakers and companies presented here today, as well as others who play in security area, they provide some tools which you can use to do similar things in multiple cases. But you can use all these tools in Google Cloud. So basically, you are not forced to use our specific native services, though our native services, they're integrated very well. So if you choose to use Google Cloud's native services, it will be much easier to manage keys, to manage security, to encryption, decryption, it all being done automatically. But alternatively, you can use any tool you choose, you like, you prefer, because we are partnering with all the key players in the security area, and most of them provide support for Google Cloud, and you can deploy their components, their software, their tools on Google Cloud.
Thank you.
That was a long answer, but hopefully it is the answer.